السلام عليكم ورحمة الله وبركاته. قوتابیانی ئازیز چۆنن ئەحواڵتان کووە؟ گەڕامەولاتان لە بابەتەکی نوێ کیمیای سیستەمی ئینگلیزی چاپتەری دووەم The term of the conjugates. Last time I have explained the ionization for the polyprotic acids, and now it's time to learn the relation between the particles in a given reaction. Because you know, when we wrote the ionization, we have seen the reaction contains too many different particles with the different charges. So really we have to know what's the relation between them in terms of the gaining and donating protons. So from now on, we only work with the Brownian-Lowry theory. Okay? I'm going to read it. Say definition manhabu, Arrhenius, Brownian, Lewis. لما دواتنا إيش بتشيدا كين Brownian Lowry. Remember, from now on, we will work with the proton transferring reaction. Which theory deals with the transferring of proton? Brownian Lowry. So we only work with the proton transferring reactions, reactions that contain transferring of proton, gainers and donors. Good. Section 3, conjugate, acid and bases. The term of the conjugate. Let's have a brief detail about the conjugates. Okay, think about this. HF, after its dissolution in water to form H3O plus by F negative. Good. Remember, which theory is useful from now on? We only prefer Brownian-Lowry theory. تناقش من با چه که دی بیله و دی باجیم نبی. تی Brownian-Lowry theory نه لویس مانده نه ارینس مانده. تناقش لگل او ریاکشنانه دکن که پروتون دونر و گینری تیده. باشه. Look at this. HF donates proton. So this is an acid. And H2O, it accepts a proton. This is a base. How about the product side? Mister, how about these? These are called conjugates. Conjugates, okay, bakuri pedarin owl, yan howly pedarin. Owl, yan howl. These are conjugates. Look at this. Where do we get F? F has been produced from what? From HF. And H3O, it has been produced from the water molecule. Stay with me, my dear. Stay focused. HF is acid, okay? So this one will be a conjugate base. Mister, that means the conjugates are totally opposite. Exactly. If it's acid, the conjugate must be base. If it's strong, the conjugate must be weak. Just like this. H2O is a base, so this one is a conjugate acid. By the end, conjugate acid, it's the acid. يعني conjugate acid here acid. Conjugate base يعني يشهر base بس وش conjugate بيودنا يعني بدس ما نكوت يلاش تشتغل. شبابي من another example. NH3 plus H2O to form NH4 plus OH negative. Get. NH3, it accepts a proton. So this is a base. H2O, it donates a proton. This is the acid one. Okay, good, agree. How about this side? They are conjugates. Conjugate, conjugate. Because we have obtained NH4 from the base molecule, so this will be a conjugate acid. Okay. Acid, the acid one, which is H2O, produced OH, it produces OH. So, acid will become a conjugate base, just like this. Easy? So now if I say, explain a conjugate acid. Okay, mister. A conjugate acid is a species that has been prepared from what? Conjugate acid has been prepared from a Brownian-Lowry base. Good? And explain the conjugate base. Conjugate base is a species that has been prepared from it's a base, so must be originated from the acid. What kind of acid? Bromocellularic acid. Okay, bromocellularic acid is a donor or acceptor? Donor. Bromocellularic acid is a donor. So, mister, when we have a bromocellularic acid in which donates a proton, it will become a conjugate base. And when we have a bromocellularic base that is accepted a proton, it will become a conjugate acid. Done. That's all. Easily. Good. Conjugate acid is a species. Conjugate acid must be produced from a bromocellularic base, and bromocellularic base gains a proton, accepts a proton. Conjugate base is prepared from the acid. What kind of acid? Bromocellularic acid when it gives a proton. It releases, donates a proton. Good. Look, let's solve the following questions. Just like this. I'm going to hide the answer to prevent cheating. Good. What is the conjugate acid for this, mister? Conjugate acid for this. How to answer this kind of question? What is the conjugate acid of this? Conjugate acid of this. That means this is a base. It will produce a conjugate acid. What is a conjugate base for this? Conjugate base for this? This must be acid to form a conjugate base. What is the conjugate acid for this? So this one must be a base. And base, if it's base, add one proton. Okay, add only one proton or remove only one proton. Because it's a base, so add one proton will become H2S. Good. This one. Conjugate acid for this. Conjugate acid for this. So this must be a base. Then add one proton. If you add one proton, it will become H2PO4 negative. Good. And conjugate base for this. Conjugate base for this. This one must be acid. Because it's acid, remove one proton, will become S negative 2. Conjugate base for this, they are totally the same questions. These two. What is the, I'll leave this for you. What is the conjugate base for this one? Good. Conjugate base, so this must be acid. If it's acid, remove one proton, will become SO4 negative 2. Easy? Good? Bash. Nice. We have a question here. In this reaction, so we have a reaction here. The conjugate acid for this, Mr. Conjugate acid for this, it means this is a base. Yeah, add one proton, will become NH4. But it must be inside of the reaction at the same time because the question says, try to answer according to the given reaction. So your answer must be inside of the scope of reaction. NH4 plus. Good. Nice. Another thing. A conjugate pairs. What are the conjugate pairs? براستی اوشتشی ناز داره conjugate pair. یک طبیعتیه. نزانی که conjugate pair شتشی زور خوشیه. It will make the other things easier. The things that are coming after of it and in which they are came before of this. Okay? يعني پیش خوی و پاش خوی مالو آسان دکه. بازدی. پیوندی باوش تانه هیه که خویندیت من و پیوندی بانش دبی کدی خوینین. او چه؟ پیر کن. كردوار خوما قسك مانه هذا كور أو دو بير يقدرينا بير يقدري يعني يعني سروشكلي أنزور بيكدسي طبيعتي عن بيكدسي سروشكلي أنزور ما عادة دون فرق برادر بدرين كور ولا أنا بير يكن بير يكن it means they have too many things in common so بير لبيرياتي لبيري خوماناتي ئاگاداربە دەتوانین برێن پێری ئینگلیزی لە پێڕە کوردواری خۆمانات یا عکسە شتەکە باشە سەیری ئەو ڕیاکشنێکە HCl plus by H2O to form H3O and Cl negative. Good? What is HCl? The acid. So this one will become a conjugate base. H2O is a base. This one is a conjugate acid. Good. What's the difference between HCl and Cl negative? First of all, you have to say, Mister, they can be produced from each other by transferring one proton. Or it's better if I give an example like a reversible arrow. HF plus by H2O, stay with me, to form H3O plus negative F. Good. The difference between HF and F. First of all, they can be prepared from each other. The first point. The first point. They must be prepared from each other by transferring one proton. So the only difference between them is only one proton. This is called a conjugate pair. So HF and F, they are a conjugate pair to each other. Another one. H2O and the H3O. Look at it. We can prepare them from each other by transferring of how many protons? Only one proton. So the only difference between them is one proton. So this is called a conjugate pair. See? Conjugate pair. Another example. H2O and OH. Look at this. Try to transfer one proton between them. You will get them. Okay? You will get them from each other. The only difference between them is only one proton. So this is called a conjugate pair. That means conjugate pairs are two species. How many species? Two species that can be prepared from each other. يعني داریم مثل پیرکان او هان پیرکان دتوانن لیکدری پریپیر بکن آماده بکن اگر یه چند پروتونش لیبستینه و دبته اویتر اویت که پروتونش بده دبته اویتر اوها اگر یک پروتون لبینیان آلوگور بکریتن transfer بکری we will get both of them from each other. So this is called a conjugate pair. وقت زیازی بنیوان تناتیا یک پروتون. Another example. Okay, another example. Look. HS negative and H2SO4. No, mister. Look at this. We cannot prepare them from each other. No, this is not a pair. Good? So our conjugate pair bono identity. Wara. Hand the example. Wara. Naroy. Legalum ba di. Say it. Are they a pair? Look at this. How many protons? They are differ from each other by how many protons? Mister, 2 protons. This is not a pair. How about this? Okay, transfer one proton from this to this, from this to this. It will become a conjugate pair. Okay, because the only difference between them is one proton. So this is a pair. Mister, these are also a pair. They will become a pair to each other. This one, okay, mister. If I remove one proton, will become Br. But for this, also true. But why it's not a pair? Look, Br must be negative. Is there any negative here? No. Pair Pasha, must be like this. Because if I remove this proton, it will become Br negative. If I add one proton, it will become HBr by one proton. This one, yeah, they are a pair. Good. Nice. And most importantly, good. So on a pair, no? One of them must be acid, one of them must be a base. The one with more proton will become the acid. The one with less proton will become a base. This is a conjugate base for this, and this one a conjugate acid for this, like this. Another one. HCl, Cl negative. Good. The one with more proton will become the acid. The one with less proton will become the base. This is called a conjugate base for this. This is a conjugate acid of Cl negative. Nice. Conjugate pair is an acid-base pair that differ by one proton in the formula. BH and H assume they are a pair to each other. Okay, this one with one more proton will become the acid. So this is a conjugate acid for this. B is a base, a conjugate base for BH. Good, nice. Wait for this. We'll get back to this. In any conjugate acid-base pair, the acid have always one proton more than the base. Okay, the acid has one proton more than the base, correct? One proton less than? No. Two proton? No. Okay, you can say this is a conjugate pair in India, not in Iraq. So the correct answer is A. Another question. In this reaction, HF plus H2O to form H3O and HF. The conjugate acid-base pair is, first of all, the conjugates are, we will have either, this is the first conjugate, or this conjugate. These are the pairs. These are the pairs. Let's find out if we have them in the reaction. So in the choices, we have two pairs. 1, 2. H2O and HF? No. H3O and H2O, do we have this? Yep. How about this? No. And this one? No. Okay. Which of the following is a conjugate pair? Is that a pair? No. The difference is oxygen, not the hydrogen. Good. This one? No. 2 protons. Not a pair. This one? Yep, mister. The only difference between them is 1 proton, correct? حبايبي من ديوان كرو 2 بروتون فرقه و 2 اتش او هيتي بيوني هذا بتا بير نابي كاكنا هلا زو ورا ابسيارة مان باري ابسيارة مان هيا. In this reaction, the conjugate acid-base pair is, let's see, H2PO4 and H3PO4. The only difference between them is 1 pair. It looks correct still, but wait. Okay. Good. For now, it looks correct. This one, B. The only difference between them is 1 proton. It looks correct. Yeah. How about this? The only difference again is 1 proton. يكسر نتيجة الجيري آگاداربوون. Okay, be careful. The question said, in this reaction. So, however, all are pairs, but which one presents in the reaction? Look, this one. H2PO4. Do we have any H2PO4 here? No, we have neither H2PO4 nor H3PO4. This one. Is there any H2PO4? No. However, we have HPO4 here, but we don't have H2PO4. This is incorrect. This one? Yep, we have this. We have this. So the answer must be inside of the reaction. But now, if I remove the reaction, then all of them, all are correct. Now, which of the following is a conjugate pair? The same choices. All are correct. Man. These are really important notes. As long as the acid is stronger, the conjugate base is weaker. If you remember, hopefully, the conjugates, they have the same property or totally opposite. They were totally opposite. Acid will become a base. Strong will be a weak. If the conjugate is a strong, if the acid is stronger, the conjugate will become weaker. This is acid, this will be a base. Just like this, like swimming. So they're working in opposite directions. Good. Example, we have a strong acid. Okay, a strong acid will become what? Strong will be weak. Acid is base, weak base. They will become flipped. Good. Now, what is the preference? Preference, it means the process that's going to be. Acids, they prefer what? To accept, to donate a proton. Bases prefer accept a proton. Acids prefer donating proton. Bases prefer accepting proton. Look. If we have a strong acid, or try to write these in in a white page. For the acids, they prefer donating. Okay? So the one that donates more will become a strong acid. The one that donates less will become a weak acid. So, acids, they have donating preference. If the acid has more preference to donate a proton, will become a strong. If the acid has less preference to donate a proton, is the weak acid. So a substance that has weak preference to donate proton. Weak preference, it means weak. Donate, it means acid. Will become a weak acid. Good. For the bases have preference of accepting proton or attracting. Okay, if a base attracts proton strong, will become a strong base. And if a base attracts proton weak, weak attractor, weak acceptor. Good? باش بابين عندك بسيارة حالكين دي لقلم بجاني من دي بابي من دي era. Question 1. A substance with less less preference, it means weak. To donate, it means acid. So we have weak acid. The conjugate will become weak, will be strong. Acid is converted into base. So the conjugate will be a strong base. Okay, strong base, it has strong preference to donate or to accept. Strong preference is correct. Strong preference is correct. Less preference, no. Less preference, no. Because the question said, how will be the conjugate, the product? The product for something that is a weak acid will be what? Okay, because it has a less preference, the product must, there must be a strong preference, more preference, high preference. Good. Strong preference. And it's a base, the preference will be for the accepting or donating, accepting. Incorrect, B is correct. Okay, a strong base. The preference of a strong base will be high or low, of course, high, not low. Bases, they attract or they release proton, they attract. High to attract proton. Good? Very nice. Okay, this is also a very nice topic. Proton transferring reaction, they favor the production of weaker acid and weaker base. You know what I mean by this? It means the product must be weaker acid or weaker base, and the reactant must be stronger acid or stronger base. So during the proton transferring reaction, we need to have a stronger reactant compared to the stronger product based on the direction. Good? Look, tamasha. The side that is strong strikes the other side. The side that is strong strikes the other side. Okay, always the direction goes, the striking starts from the strong to weak. The direction goes from stronger to weaker. So if the product is weaker, it will favor reverse. If the reactant is weaker, it will favor forward. Just like this. Okay. Assume we have a product and reactant. This is reactant and this is product. If the reactant is stronger, I'm not going to mention this. If the reactant is stronger and if the product is weaker, so now how will be the direction? The direction will be from the strong to weak. Oh my God. Oh, good. Or if the reactant is weaker and if the product is stronger, now the direction starts from the stronger to weaker. So it always favors the production of weaker products. Very good. باب سياران حالكين دي لقلم بدي جاني من أوتا أو بسياري بيان ورا أو بسيارة معناه. I'm going to to solve this question here. However, you have the solution from down below. Try to answer the following questions, my dear. This kind of question, it's not in the book, but this is a collection. It's a quick revision for too many different topics together. But the deception and the lecture Tamam? For the aqueous solution of perchloric acid. What is the perchloric acid? Let me hide the solution. Just like this. Just be patient. Here. Nice. Good. Perchloric acid is HClO4. First thing, just write the reaction for the ionization of perchloric acid plus by H2O. This is a strong acid. Okay. I'm not going to mention the direction. Then to form H3O plus ClO4 negative. Good. Try to identify the proper direction, the favorite direction in this aqueous solution. Just wait. Identify the pairs. This with this. The one with more proton is the acid. The one with less proton is the base. Is there another pair? Yeah, mister. Here we have another pair. The one with more proton is the acid. The one with less proton is the base. Nice. Okay. Here comes our reaction. بنسوي عقلا ورا pair كان ديالك. The first thing, write the reaction. The second thing, find out the pairs. Then the strength. Start from the neighbor of H2O. Start from the neighbor of H2O. HClO4, it's a strong acid. It's what? A strong acid. So water must also be strong. If it's weak, water must be weak. If it's strong, water must be strong also. So this is also strong. How about this side? They must be weak. Weak. دوباره دکمون. First, write the ionization reaction. Then identify the pairs. آیا پروتونش زیادتر دبته acid، آیا پروتونش کمتر دبته base. Then start from the neighbor of H2O. If it is strong, water must be strong. If it's weak, water must be weak also. On the other side must be reversed. Good. So as I told you, always the stronger side strikes the weaker side. So now the direction will be forward from stronger to weaker. Why? Let's write the proton acceptors and donors. These are acids and these are bases. Good. Acids, it means the donors. Bases, the acceptors. Nice. How many acids do we have here? 2 acids with 2 bases. The acids are H3O and perchloric acid. Okay. Perchloric acid is HClO4, H3O, and which one is a strong acid? This is a strong acid, and this one weak acid based on the reaction. This is stronger, and this one is a weaker. Weaker. Good. How about the bases? We have 2 bases. The first one, H2O, and the ClO4. This is stronger base. This is weaker base. Yalla. In the aqueous solution of perchloric, the stronger acid is perchloric. The weaker acid is H3O. The stronger base is H2O. The weaker base is ClO4. Then, this reaction favors forward Y. Blame mister, just say mister. The acids are fighting, they are in competition with each other in donating proton. The weak one, the weaker cannot compete successfully with the stronger. Look, the weaker one cannot compete successfully with the stronger one. Away weaker, ناتوانه compete, ناتوانه پیش برکه stronger بکه. Okay? The weaker one cannot compete successfully with what? The stronger. Look, H3O cannot compete successfully with HClO4 in donating. And ClO4 cannot compete successfully with H2O in accepting. Therefore, it favors forward. I'll repeat the whole steps. Write the reaction. Then the pairs. Then start from the neighbor of H2O. أوي لتنش آوية لقلوي دس بيكا. أجر أو strong be آويش stronger. أجر أو weak be آويش ده weak be بابي من. Okay. Then لا كده عكسها. أوي كوا stronger strike weak دكا. Okay. Why? Because the weaker one cannot compete successfully with the stronger one in donating or in accepting. Done. One more example, and I'll terminate the today's lesson. Or I'm finalized. Okay. NH3 to form NH4 plus OH negative. Good? This is the reaction. This is called aqueous solution of ammonia. The first one, write the reaction. Then start from the neighbor of H2O or the pairs. I mean, what a pair can diary kabab di. Pair can ba diary kain di. Our pair كمان ده بيت acid أو proton چیزورتر أو سواره أو سيه كاتو acid. And this is a base. دو كده عكس ده بنو. أو pair كده كمان proton زور أو H چیزیاتر أو ده بيت acid. And this one is a base. Good. پاشان لکامه دست پیدا کنین لزیرانه آوی دست پیدا کنین. We will start from the neighbor of H2O, the friend of H2O. This is a weak base, so water is a weak. This must be strong. This one also is a strong base. Now stronger strikes weaker. Why? Okay. In this aqueous solution, which one is the strongest? Is the stronger base, or is a stronger base OH? The stronger acid NH4, the weaker base NH3, the weaker acid H2O. Now write the acceptors and the donors. Acceptors and the donors. Good. This is D. Okay, this is D. D. Acceptors, it means bases. Donors, acids. Nice. Okay. Look, the bases are, we have two bases. The acids, we have two acids. The bases, we have OH, which is a stronger, and the NH3. This is a weaker one. Cool. Here, the acids, NH4. This is a stronger. And the H2O, it's a weaker one. Good. Now, this reaction favors reverse. Why? Because the weaker base in which NH3 cannot compete successfully with OH in accepting, and H2O cannot compete successfully with NH4 in donating. That's why it will favor reverse direction. You دارم لي تيجي يشتغل. لو أنا دهاتو إن شاء الله بيتان شاد ما ليرو دست پیدا کنه او بسیاره رو هم explain کرده همین بزوانی رو باز کردی او چه ها proton donors acceptors رو بزوانی رو باز کردی او بسیاره که دی امونیام رو با حل کردی لگه پرکلوری چی او تایی تازه او شیان دبیت هومورچ خود او بسیاره حل که باشه باب من عاقل و بقسم که so درسی دابی لیرو دست پیدا کن ionization for the polyprotic acid اوشن باز کرده بو ایترک دگینا بابتی امفوتریک الامفوتریشی را با عزیزەکانی خۆم شاد دەبمەوە ئینشاڵڵە سەلامەت بن سەلامەتی بێکێشەی سەری هەموو شتێکیان ئەوەندی هەموو تێدەپەڕێ ئینشاڵڵە I'll see you in the next video. Stay safe. خواتان لەگەڵ